Hello and welcome to the TID Water and Power Podcast. I'm your host, Constance Anderson, and on this month's episode, we're discussing the modernization of our irrigation system. TID's irrigation system was built in the late 1890s and operates in much the same way as it was originally designed, flowing by gravity from the Grange Dam to and throughout our service territory. TID cares for our 130-year-old system through rigorous annual maintenance. However, regulatory mandates, more frequent extreme weather events, and changing customer expectations requires that the district continue to update and modernize the irrigation system to meet today's needs and be ready for the future. On this episode, I'm joined by TID Civil Engineering Department Manager Phil Govea to discuss how TID's irrigation system works, what improvements have been made to the system over the years, and the long-term plans for the system. Phil, thanks for joining us.
Thank you. Happy to be here.
All right. So let's jump right in, if you would. Tell us a little bit about your background.
So I'm a civil engineer. I've been in the field since 1992. And so I have just over 33 years of experience, all in the public sector. I've worked for a variety of wastewater agencies over the years, joining TID in 2017 as the civil engineering department manager, responsible for the irrigation capital plan, overseeing right-of-way survey divisions, SCADA management, and special projects, things like Project Nexus.
Oh, yes. Very good. So today we're discussing the district's plan to modernize our irrigation system, but I think it's important to start by explaining how our irrigation system actually works today and how it has worked for really more than a century.
Yeah, so our irrigation system, it's a gravity-based system. Water is released from Don Pedro, flows a short distance down the Tuolumne. It's diverted at the Grange Dam, runs through our upper main canal system into Turlock Lake. That upper stretch, we call that the upper reach. It's more than 100 years old. From there, the water flows into Turlock Lake. Turlock Lake is, I call it a white spot in the system. It's a regulating reservoir, and it allows storage of water, which is, it offers a great deal of flexibility because supply oftentimes does not meet exactly demand meaning irrigation customers, irrigation requirements, and we may be doing releases out of Don Pedro that are power generation related, and that water can't necessarily find a home.
Sure.
Especially in the shoulder months where demand is low, and so it's you can store water in Turlock Lake and then release it later when there's demand. From there, water is released from Turlock Lake typically once per day. Runs through the main canal, which is similar in size to the upper main canal. Flows to what we call the division. It's really a split between the Turlock main and the Ceres main. And then from there, it flows to the various laterals that make it throughout the entire irrigation system. So, as I said, it's a gravity-fed system. So, the elevation of the water is at its high point at LaGrange, and then just consistently flows to lower elevation all the way down to the spills in the Tuolumne, the San Joaquin, and the Merced rivers. So, and our system, I kind of call it a hybrid between manually operated and automated. Mm-hmm. We have some portions that are automated, but a lot is still hands-on.
Okay. And so again, just to kind of get that frame of reference, water comes down from the watershed into Don Pedro, released through Don Pedro, eventually makes its way down to Turlock Lake. And that's kind of the middle point, dividing the upper reach, as you mentioned, and then the lower part of the system.
Right.
Okay. And so then once it leaves Turlock Lake, then it's essentially in TID's irrigation system.
Right. Irrigation system as in ready to find a home on farmland.
Right. Exactly. Okay, great. Well, thank you for that. What are some of the complications encountered with a gravity-fed system?
Just kind of by definition, it's water inefficient, unfortunately to say, but that's just the reality of it. It's one of those things where it's not like the plumbing in your home where you can just turn it off when you don't need it and turn it on when you need it, and it instantly shows up or is instantly turned off. So the water really needs to have a home. There's no stopping it.
Sure.
In a gravity system. And so ideally the home would be finding it, putting it onto land. But when there's no land available, the demand's not there, growers are, hey, I've got enough, no more. It's got to go somewhere. And that somewhere is spill, is then just released to the rivers, the Tuolumne, the San Joaquin, or the Merced.
And I think it's kind of important to note that is the way our forefathers designed the system to operate, right? That gravity pull throughout the system, knowing that that opportunity to spill to the rivers was there. In the last 130 years or so, TID has worked hard to reduce those spills and make updates to the system to be more water efficient in a gravity-fed system.
Definitely. And yeah, it didn't mean to downplay or besmirch the irrigation system, the gravity-based system at all. Sure. Yeah, it's a innovative system for its time, and Absolutely. It still works quite well. But it just has this component where it's water inefficient, and for the first 100+ years, it really didn't matter all that much. Well, these days it does. It's becoming more and more of an issue, and we're working, as you say, to tighten things up and capture those spills.
That's right. Very good. All right. So give us an idea of kind of the size and scope of the irrigation system. How widespread is our system?
Yeah, it's impressive. We have over 250 miles of canal.
Wow.
92% or about 230 miles of the canal is lined. We irrigate roughly 145,000 acres of farmland through approximately 1,400 side gates, including 1,600 miles of improvement district pipelines.
Okay. So that covers some pretty good territory then. All right. So TID made its first irrigation delivery roughly 125 years ago. And while the system, as we mentioned, operates very similarly to how it did then, we've continued to update and modernize the system throughout the years. For example, you mentioned the specific number of miles of canal and how many of those miles are now actually concrete lined, which originally they worked with what they had, which was dirt and clay, and none of them were originally lined. So that's just one example of some modernization that's taken place. What are some of the other modernizations that have been made more recently?
Probably the most significant is going after or installing regulating reservoirs. And it's finding a way, building storage mid-system, mid-irrigation system to allow the mismatch between supply and demand, which when there's an oversupply, that water typically, historically, has just been spilled to the rivers as intended. Now, through these regulating reservoirs like the Lateral 8 regulating reservoir and the Series Main regulating reservoir, that water can be parked temporarily in those reservoirs and then brought back when the demand is there.
Are there any plans for new regulating reservoirs in the system?
There is. The lateral 5.5 regulating reservoir is the next one that we're considering. The land for that reservoir has already been purchased, and it's located near the Harding Drain, and it is shovel ready. So it is designed 100% in-house. We've also obtained environmental compliance for the project.
Great.
So there's also been automation of certain facilities, the drop structures in our system. We've automated actually 50 drop structures so far, and primarily those are probably the most important or most critical locations in our system, like the head of each lateral, is now automated. Mm-hmm. So instead of being hand actuated or
with an actual turn crank of some sort.
Right.
Yeah.
Right. Instead of that, it is now an automated gate that opens and closes as we see fit, based on whether we want a certain flow to be provided or a certain elevation, water elevation to be provided. So we're also looking at proliferating that automation throughout the entire system.
So we've completed a lot of modernization projects over the last decade or so, but there are still big plans in the works, from what I understand. What's next for our irrigation system?
So we presented a comprehensive water plan to the board a little over a year ago, where it really captured all the things that we're trying to accomplish with a water plan, and that includes things that don't end up with a capital facility. Things like what the hydrology department is doing, what regulatory affairs is doing, what construction and maintenance and water distribution, what the civil engineering department are doing. So there's components, like I said, that work that's important, that is included in that comprehensive water plan that was spelled out to or presented to the board. But then of course it does include significant infrastructure improvements, and we've grouped those improvements into kind of two buckets. The first bucket is the large scale projects for water supply augmentation, things like adding new offstream storage reservoirs like Montgomery Reservoir, Cardozo Ridge, a spillway raise to Don Pedro, intertie between Don Pedro and New Maloney's reservoir. So things big, large scale projects like that capture are intended to capture a lot of water. Yeah. And they sync up well with the flood rights water application that we submitted a couple of years ago. And then the other bucket is, we call it the lower system Canal Modernization Plan. So that's a plan to fully automate, fully modernize the irrigation system from Turlock Lake to the spills. And we're projecting a 20-year plan, and that involves automating the remaining drops in the system that aren't currently automated. So that number's 338 drops in our system. And to demonstrate what that would look like, we have an upcoming pilot on the series main. We call it the TCC, or Total Channel Control pilot of the series main, and it will allow us to demonstrate the benefits of full automation of a canal system.
Right. And what are the key drivers behind the changes to the lower system canal modernization plan?
Yeah, a lot of different drivers, things like FERC relicensing, Bay Delta plan, the large regulatory requirements that are facing us. There's also just the changing hydrology, the wetter wets, the drier dries. We have aging infrastructure. We have portions of our system that are over 100 plus years old. We also have changing customer demands. They are looking for changing from flood irrigation to micro drip irrigation, and so all those are drivers that impact how we do business.
So would you say that the lower system canal modernization plan focuses more on long-term efficiencies, or specifically on water savings, or kind of what's the goal there?
Really it's a combination of those. Once it's complete, we're estimating that we'll save on average 44,000 acre feet per year.
Wow, that's significant.
Which is very significant. And the goal is to have zero unintended spill in our system. And sometimes people will ask, well, what do you mean? So you have intended spill? Well, yeah, from time to time, in a flood year, we're running water through our system, trying to take pressure off the Tuolumne, and we'll run excess water, surplus water through our flood water through our system to take it to the Merced or the San Joaquin or lower in the Tuolumne in order to take pressure off the upper Tuolumne.
Sure. You mentioned that the Series Main Total Channel Control pilot project is the first element of the plan to be implemented. Can you tell us more about that project specifically?
Yeah, that project involves converting a portion of our irrigation system to total channel control, or TCC. And what that means in the pilot area, there's 10 drop structures, 68 side gates, that serve over 7,000 acres of farmland that will be fully automated. So the drops will be automated, the side gates will be automated, as well as we'll be using Rubicon's ordering and scheduling software that will automate the ordering and scheduling process.
Okay. And you mentioned Rubicon. Is that a brand name for the gates, or?
That's a company that got started in Australia, and they have significant installations all throughout Australia and other parts of the world. And this will be the first in the U.S. For a Rubicon system, a total channel control system in the United States.
Oh, very cool. Well, TID definitely likes to be the first. Now, I want to just touch on something real quick. You've mentioned replacing and fully automating drops and side gates. What does that mean, actually, for them to be fully automated?
So really what that means is we're changing how our system will operate. Our current system is described as a upstream control system, meaning upstream as in Turlock Lake. Makes one release per day based on the orders collected the previous day. So that one supply point really dictates how our operations go in the lower part of this system. Versus putting in a Rubicon system, you're changing from upstream control to downstream control, meaning, so consider the lowest point in the system, the last parcel at the end of a canal, and it needs another 2 hours of irrigation longer than anticipated. Well, in our current system, we can't supply them with surface water because we've made the releases that we've made out of Turlock Lake, and to meet the additional demand, we'd have to make another release out of Turlock Lake, which would take 4 to 5 hours to get there. It just isn't practical. So we would turn on a groundwater pump in order to meet that, and meet that demand. With the Rubicon system, it will meet that demand by so we call the Rubicon calls the water between the drop structures pools, and so the pool that is serving the lowest field, the lowest parcel in this example, the system would continue to meet that demand. The water level in that pool would drop and drop. The pool upstream of that would backfill and fill in the water that is dropping in that first pool to meet that demand, and then the pool upstream of that would fill the preceding pool, and so on, all the way to a regulating reservoir or all the way up to Turlock Lake. So
it sounds like you're almost taking a gravity fed system and sort of reversing that.
Yeah, getting close to a closed system. Still not completely closed, but using the water available in the system, in the pools that are all throughout the system, to meet demands as needed.
And when you say closed system, define for us what that looks like.
Closed system, think of the plumbing in your house for drinking water, where it's piped and it's constantly pressurized, and you turn a valve completely on demand, turn a valve open and close when you're done.
Okay, and this could someday be our system.
Close. We like to say near on demand, but not completely on demand.
That's fair. Okay. And then you mentioned in utilizing the Rubicon software, their programming of the system, we're able to input what the individual grower demands are, what the irrigation need is, and then that factors into how the different pools are regulated with the amount of water in them?
Yeah, so the customer will interface with the Rubicon system. They'll place their order, and the system will schedule them. And so the system will be aggregating all of these orders together, and making releases out of Turlock Lake multiple times a day, making releases out of the regulating reservoirs. Or pulling back flows from the regulating reservoirs, or pulling back flows from Turlock Lake to try and precisely meet and match irrigation demand.
Very cool. Okay, and you mentioned that this is a pilot project, and so how long will the pilot project continue, and what happens at the end of the pilot?
Yeah. So it's a 2-year pilot, and it'll go over 2 irrigation seasons, the 2026 and 2027 irrigation seasons. And at the end, this is what we intend to is gather up all the lessons learned and provide a report out to the board. And this is what we found. This is what we learned. This met our expectations. This didn't meet our expectations. Here are things that we could do differently. So just kind of like any kind of pilot. Lessons learned to then make those adjustments going forward as you then advance this technology throughout the rest of the system.
Sure. And what are some of the benefits you're hoping to see come from the Ceres Main TCC project?
So the reduction in spills and unintended spills, we're looking to increase the water delivery reliability and consistency, reduce customer wait time, minimize the use of groundwater pumps. With the fact that we could make multiple releases out of Turlock Lake, as well as the regulating reservoirs, then that would drive down our need for groundwater supply, which in turn then will improve the water quality to our growers, because we're using more surface water, which is just by and large better water quality than groundwater.
Okay.
And one of the other benefits of this pilot is we'll also be testing and piloting different construction techniques for the drop structures.
Oh, okay. What do you mean by that? Piloting different construction techniques?
So we're going to compare our current, I'll call it traditional construction method, which is tear out an existing drop, build forms, wooden forms, pour concrete in place in the field to form a new drop structure that can then support the Rubicon gates and technology. So that's the traditional method. What we're also there are some techniques that construction and maintenance is planning to use on the traditional approach. They're also planning to the first test then would be comparing it with bringing in we call it speed shoring or speed forms, I should say. One of the time-consuming elements of pouring concrete, especially walls, is you have to use plywood and 2x4s and create forms. And that takes a long time. Whereas if you can use prefabricated or sometimes called speed forms that meet your specifications, you can put those up quickly, pour quickly, and that speeds up construction time. So that will be one of the approaches that we'll test. And then the last method will be prefabricating as much of these drops that we possibly can offsite, say during the summer months, and then bringing portions of a prefabricated drop structure in to the site, placing them, and then pouring a floor, tying it all together. And so we're going to compare all three of those to just looking for ways to reduce cost and speed up our construction efficiency.
Sure. Because as we've mentioned in previous episodes, there's only a short window when the water is out of the canals and we have the opportunity to install these automated drops and make these repairs and take care of maintenance. So the faster it can get done safely and accurately, the better.
Yeah, absolutely. And that window is just getting shorter and shorter. Plus our construction maintenance department, they have a lot of other duties related to canal maintenance, in canal maintenance, as well as embankment work and so forth. And then there's just the fact that not always are the canals just completely empty. There's running water for groundwater recharge projects, flood water, that sort of thing. It just presents unique challenges. There's a variety of different things, and so that just shrinks the available window for construction to happen in the off season. So the need is there to find ways to just be faster, more efficient with our in channel, in canal construction.
Sure. It's almost like you've got a mini pilot of your construction techniques going on within the larger pilot project.
We do.
That's
we
great.
Do. Yep.
Very cool. So if I may ask, what is the estimated cost of the Series Main Total Channel Control pilot project?
Yeah, we're looking at about $4.3 million in estimated cost, and the bulk of that will be spent the fall of this year and into the winter of 2026.
Okay. When that construction will take place.
Exactly.
Very good. Well, I look forward to seeing the results of the pilot project. That's exciting. So good luck to you and your team on that. What are some of the challenges that come along with the projects in the lower system canal plan?
Well, the biggest challenge, I think, is moving from Rubicon's level 4 system, which we have today, throughout a lot of our lower irrigation system, moving to level 5. And so level 4, what that means is automated drop structures in channel, which we have 50 of those, and we're well experienced with using those facilities and those products, and they work very well. And we've learned a lot, and we're pretty savvy at operating those. But we are operating those. Managers are making decisions on we want them to operate a certain way, either deliver a certain amount of flow or maintain certain canal water elevations. So we're making those decisions. Whereas level 5 is you're allowing the system to interact with our customers through ordering and scheduling, and then the system is automatically meeting all of the orders that our customers have made the previous day. So now this system, the level 5 system, is operating and meeting demands, and we're monitoring, but the system is meeting those demands. And so this level 5 automation is working very well and has worked for many, many years in Australia and other parts of the world, but it will be a first-time operation, level 5 operation in the United States.
Okay.
We have reached out to water districts primarily in Australia for lessons learned, and they've been very accommodating. But it just has never been done here before. And what we found with the water districts in Australia is their infrastructure, especially their canals, have quite the amount of capacity. In fact, they almost look overbuilt.
Oh, wow.
And then the pipelines that serve our what we call our improvement district pipelines, they're similar improvement district pipelines. In a lot of cases, it's one customer per pipeline. And so that simplifies things versus our experience here is we often have multiple customers on a single pipeline. So adapting that system, the Rubicon TCC system, to our situation is definitely a challenge.
Okay. So what then is the total cost of the lower system canal modernization plan?
Yeah, we're estimating $160 million over a 20-year schedule, and we're definitely doing everything we can to continue to seek out grants to just minimize impacts to our ratepayers.
Yeah, absolutely. And along the lines of the grants, can you tell us a little bit more about TID's kind of philosophy towards acquiring grants?
We're going after early and often, as I say. We're going after as many as we possibly can, and just to minimize impacts to our ratepayers. We've been successful in a number of grants recently. Series Main Regulating Reservoir we were awarded a grant for that project. Floating solar for the Lateral Loop project. And also we were awarded grants for the Turlock Lake Dam Rehab project, and then automation of the main canal from Turlock Lake down to the division. Oh, great. Wonderful. And what's that process like? Now that we have been the recipient of some of these grants, are you noticing a rhythm to what makes for a strong grant contender? I like to say that there's an art and science of obtaining grants. And one of the things that's really important is to have the project shovel ready. And what that means is it's 100% design and it has environmental clearance. And what that means is to agencies that are providing grants, is they look at that and they say, okay, if we award to this agency, that project's going to move and be completed sooner than another project that's just getting off the ground, just concept level. And so, oftentimes the funding agency, their metric is how quickly they get tax dollars to work. And so when TID comes forward with projects that are shovel ready, we definitely score better. We compete better against other projects by other agencies.
And I would think, too, that kind of shows a level of commitment from TID towards the project going forward that maybe the agency offering the grant would be responsive to.
Absolutely. And they also, another component is if you have received a grant from a particular agency and you made good on your schedule and did what you said you were going to do, that goes a long way when you are reapplying for another project and they realize that, yes, you did what you said you were going to do in a timely manner and you got it done. And so they know that, okay, if we award to you again, you'll likely get it done when you said you would. Excellent. Very good.
Okay, excellent. All right. Now, you had mentioned early on the comprehensive water plan, which kind of lays out the long-term vision for what happens with our system. Can you tell us about some of the other projects that are included in the comprehensive water plan that we anticipate rolling out?
Yeah, the Upper Main Canal Rehabilitation Project is a very important one. So this is a stretch of canal from the diversion point at LaGrange down to Turlock Lake, and it's a facility that's over 100 years old. It's been modified several times over the years, and it's just it's an aging piece of infrastructure. It needs to be replaced. It serves a critical role. It is really what we kind of call the artery of our system. And we've looked at different ways to rehabilitate it, and it looks like a rebuild in place is the most cost-effective approach. And then we're estimating that's going to cost about $140 million to do that.
Okay.
Another project that's important in the comprehensive water plan is the Turlock Lake Dam rehab project. It's a seismic retrofit to several of the saddle dams that make up Turlock Lake, and so that's also a project where we've received a phased grant. Phased meaning we were selected to receive design and environmental clearance monies. And once we're fully complete with both of those, then the expectation is we would get funding for a portion of the construction. Altogether, that project is a $20 million project.
Okay. All right, so we've got the TCC pilot project, potentially fully automating the entire irrigation system, the rehabilitation projects you just mentioned. Each of these are substantially large undertakings, and never mind the fact that we're looking to implement all of these within the next 20 years. That's a significant commitment to maintaining our infrastructure.
It absolutely is, and it falls in line with our strategic plan and focusing on reliable service and affordable service to our customers. There's a lot of components that are of a comprehensive water plan that are visionary and innovative, and certainly that's a kind of a founding principle for TID. So we're continuing that legacy. And all of this modernization work, we think, just syncs up and fits right in with our core values, and always looking for ways to be more efficient and optimize our operations.
Great. Well, now I'm going to kind of put you on the spot here for a minute, Phil, because we have recently learned that you will be retiring from TID later in 2025. How is all this going to get done without you here to drive it forward?
Well, fortunately, this plan does not hinge on me. We have a lot of talented staff all throughout the district, and so TID is in good hands, definitely going forward. So I'm not worried about it at all. Very
good. Well, and hopefully it will. The progress of these various projects will entice you to come back and visit every now and again.
Will do.
Very good. Well, Phil, thanks so much for being with us on the podcast today.
Thank you.
Thank you for tuning in to the TID Water and Power Podcast. You can find TID on Facebook at facebook.com/TurlockID, on Instagram and Twitter at TurlockID, and on LinkedIn as the Turlock Irrigation District. I'm your host, Constance Anderson. We'll see you again next time.